instead of an equal sign? That's good. She's my checker. I like it. An equation that has an equality sign, less than equal to, greater than equal to, instead of an equal sign. You actually first learned inequalities way back in grade 4, and they probably taught you the alligator eats the bigger number. Have you heard that before? It drives me crazy because then what do you do when there's a variable? So I always say less than looks like an L. Greater than does not look like an L.
Do you want to know how I remember? Because you know how like they use the less than 3 signs apart?
Oh, there you go. So less than looks like an L. It does not alligator. Let's get alligator out of there because now we're going to have variables. So this is what you did with graphing in grade 9. So I'm just going to put this back into your head before we do the new stuff. So you would have graphed things like x is less than -3. Does that kind of look familiar? So we would go to -3, and then you need to decide if it's an open dot or a closed dot or what we call a white dot or a black dot. That should kind of be familiar. An open dot or a white dot is if it's not and equal to. A black dot is if it is or equal to. So this one doesn't have that little bar underneath, so it's going to be an open dot. And then we just need to put an arrow. Less than -3, is that to the right of -3 or to the left of -3? It's to the left of -3. So there's how we show all the values that are less than -3. And the difference between an inequality and an equation typically has 1 or 2, maybe 3 answers. An inequality has infinite number of answers. Give me one number that's less than -3. Yes, give me another one. Yes, give me another one. Yes. Yes. Give me another one. Yes. How many times can we keep playing this game? As long as I want to. Exactly. X is greater than or equal to 4. We go to 4. We pick a white dot or a black dot. Which one is it going to be? Black dot because it's or equal to. And then we just need to decide is it going to the left or going to the right? Where are the numbers bigger than 4? To the right. No, white dots if it's or equal to. We don't put we fill them in if it's black. So this one did not have in part 1 and it did have in part 2. The difference is if we go back up to part 1 or whatever you want to call it, is -3 a valid answer? Is -3 less than -3? No. Is 4 a valid answer? Is 4 greater than or equal to 4? Yes. So the white means it's not included. Black means it is included. White means that value is not an answer. Black means it is an answer. Oh my goodness, what was this? Well, we saw this with domain a couple units ago. And this means what in English? Less than x less than. It's an English word. It means between. So this particular inequality is saying x can be between -2 and 5, including 5, not including -2. So we just do them in order. We go to -2 first. Is it a black dot or a white dot? Then we go to 5. Is it a black dot or a white dot? And then to show between, we just join the 2 dots. So do you see under this first symbol, there's no little bar? If there's no bar, it's white. If there's a bar, it's black. So here's basically the 3 situations. Here's a less than graph. Here's a greater than graph. Here's a between graph. Go ahead and graph 4 and 5. I was waiting for you to do it. If you weren't going to, I was going to. For the 4th one, I'm going to go to 3. Am I going to put an open dot or a closed dot? Am I going to point the arrow towards the left or towards the right? And you notice the arrowhead always kind of matches the symbol. That's how I remember. So the arrowhead matches here. If we're going the other direction, it kind of matches. For the between, I'm going to go to -7 first, black dot or white dot. Then go to 1, black dot or white dot. How do I show between? So this would have taken us a whole class in grade 9 just to teach you how to do this. Yeah, that was a whole class in grade 9. James, what are you staring at your crotch for? It's kind of weird. Kind of weird. Here's grade 11, is we're going to solve quadratic inequalities. It is. We have solved quadratic equations in Unit 3. Now we're just adding the inequality piece. We're going to do a graphic solution, then we're going to do an algebraic solution. Graphing solution. Use the graph of y equals x squared minus 2x minus 3 to solve where x squared minus 2x minus 3 is greater than 0. So we got to start by graphing. We have 2 methods to graph. What are the 2 methods? X-intercepts, axis of symmetry, vertex, and the other method is vertex, direction, width. Which one would you like to use? So you want to complete the square to get the vertex? Okay, walk me through completing the square. Where did this first plus 1 come from?
2 divided by 2 squared.
Where did the minus 1 come from?
Same as the plus 1. X take away 1. Direction is up. Width is 1, 3.
So that was from Unit 4. All we're going to do now is the next step and talk about this inequality. When you see greater than 0, what that means in terms of the graph is all the points have to be above the x-axis. Because above is where y is greater than 0. Let's imagine that was a less than sign. Where would all the points have to be? Below. Okay? So I'm looking at this graph and I want to know where are all the points that are physically above the x-axis. So it's going to be this left-hand piece and the right-hand piece. Everything in between those is below the x-axis. Still with me? Now I just need to state, well, what are these values? So let's do the left-hand side first. It's all the numbers that are less than what value? -1. And what is that -1 in terms of the graph? It's the x-intercept. So x has to be less than -1. Now, why did I not put the or equal to? Why did I not put the or equal to? Because there's no or equal to in the question. So the question and the answer match. If there was an or equal to here, I would put an or equal to here, but there isn't. So this is the left-hand section. Now I've got to say the right-hand section, so I'm going to put a comma. X is, how do I say to the right? Greater than, what's the value? 3. There's the solution to the inequality. So if I was solving this as an equation, my answers would have been x equals negative 1 and x equals 3. Because I put the inequality sign, now I'm going to have infinite answers. Where are the solutions? Anything above. So it's all the numbers that are less than the first intercept and greater than the second intercept. So no longer will you just have blah and blah as your answer. You're going to have some kind of interval notation to represent infinite amount of answers. So there's graphically what's going on. Here's how algebraically. Step 1, solve the equation. So it means forget that there's an inequality sign there, go back to unit 3 and solve a quadratic just like we'd solved before. How many different ways are there to solve a quadratic? Now, steps 2 and 3 are going to seem weird when I write them out in English because they're not going to make sense, and they may seem weird when we do the first example. Once you see a couple examples, you're going to see they're the same steps every time. Kevin, take out your earphone. Step number 2, write the solutions. On a number line. I had a student about 6 years ago, maybe 7, in grade 11, thought until I wrote it out it was a number lion, like grr, roar. They actually thought that.
That's my favorite thing I've ever heard.
Yeah, it's not a number lion. No, it's a number line. Line. Again, step 3 is going to seem weird until you see an example, so just go with me. Test a value in each interval. Test a value in each interval and decide if the value is true or false. Test a value in each interval and decide if the value is true or false. I know that seems weird, just bear with me till we get to the example. Write the intervals that are true. Write the intervals that are true. And then just a little note, match the notation in the question. Match the notation in the question. Again, I know it's weird because you've never done these before. Just bear with me. The first example, you might be like, You're going to see just like the max mins in a second, all the examples are going to have the exact same steps every single time. But quadratic inequalities are completely new to you, so don't panic. Your title will be Solving Quadratic Inequalities. Oh yeah, number 2, thank you. Now I'm going to have to sanitize that flower. Thanks a lot. Step number 1. Just ignore that crazy new sign. Pretend like it's a question from Unit 4 that you've done now 1,000 times. Pick a method and solve. What method would you like to use? You want to complete the square? I would not want to complete the square. I'd probably want to factor, but it's totally up to you guys. I don't care. We'll race. You complete the square, I'll factor. We'll see who gets there first. I'll just point out you chose to sit behind her. And it's only Thursday. Like waiting for you to offer because I factored like a bajillion times in my life. Confirm. Split and solve. Step number 1 should be okay because we've done that a bajillion times. Step number 2 is where it starts to get new. I'm going to draw a number line, and I'm left brain, so I'm using a ruler. I don't care what you do. Now I'm going to draw a lazy number line. I'm actually not going to put all the little ticks on it. I'm just going to put them in order. -1's about there, 5's about here. I really don't care about all the little ticks. Just make sure you're putting them lowest to highest because the negative comes before the positive. I'm going to switch colors for step number 3 because I'm going to do it on the number line. I don't want you to confuse it later. Step number 3 is I need to pick a number in each of these 3 intervals. It doesn't matter what number you pick. I'll give you some suggestions in a second. I'm going to pick a number that falls in this part of the number line, a number that falls in between those 2 values, and a number that falls on the right. I'm going to take each of those 3 numbers and sub it back into the question, and I want to know, does it make the question true or false? You can pick any numbers you want. The easiest numbers to pick are 0s, 1s, and 10s because it's easier to do the mental math. So what I tend to do is find which interval would 0 be in, and I do it first. So would 0 be over here? Would 0 be in the middle? Or would 0 be on the right? So I just put a little 0 just to show myself, or the marker, I'm about to pick 0. Now I need a number over here. I would tend to pick -10 just because it's easy to do mentally. You can pick any number you want. You could pick -5.789 if you wanted to, but that's not an easy number to calculate. And then I come to the last one. Again, I need to pick an easy number. I'm going to pick 10. Okay? You can pick any number you want. These are just really easy to calculate. So I'm going to show you for the first one exactly what we're doing, but normally I would not write down this step. This is some mental math. So what I'm doing is taking 0 and putting it back into the original question. And what I want to know, is that true or is it false when I do that mental math? So 0 squared, 0. -4 times 0, 0. That's why it's easy to do mental math with 0. All I'm down to is -5 greater than 0. True or false? -5 greater than 0. That is false, so I'm going to put an F above my 0. I'm going to do the same thing with -10, so going back to the original question, subbing in -10. And again, I wouldn't normally write these out. I'm just showing you for the first one what we're doing. And the reason I picked 10 is because it's an easy one to square and it's an easy one to multiply. So -10 squared, 100. -4 times -10, 40. So I'm at 100 plus 40, 140, minus 5, 135. 135 greater than 0. True or false? Do you see why I picked 10? Or -10 in this case? Just because it's easy to do. Again, you can pick any number, it doesn't matter. In the last interval, doing the same thing this time with +10. (10 squared), -10 times 4, or -4 times 10. So 100 minus 40, 60. 60 minus 5, 55. 55 greater than 0. True or false? You with me so far? Step number 4 is we always want to pick the true regions. We're never ever going to pick a false region because that doesn't make sense. We want the region that makes this true. So all I need to do now is state the answers. How do I say all the numbers that are to the left of negative 1? How do I put that into math? All the numbers that are to the left of negative 1. X is, left is, less than negative 1, comma. Now I need to say all the numbers that are greater than 5. So X is, sorry? Oh, thank you. X is greater than 5. And the last step is just check the question. If it has an or equal to, we put an or equal to. If it doesn't have an or equal to, we do not put an or equal to. So final answer is X is less than minus 1, X is greater than 5. We just check if it has an or equal to. So if it has a little bar, we put little bars. So it's to the left of negative 1, and so it's going that way. That's exactly what I do, is I put the arrows and I match the notation. So to the left is less than, to the right is greater than. What this number line is really what we did in example 1, and I don't want you to draw on yours because it's going to mug up your notes. But what this really is a parabola that's going like this. These happen to be the x-intercepts, and because it's greater than, we want the regions that are above the x-axis, and that's what we've done here. So it's the same thing as doing it graphically, we're just doing it on a number line instead. Again, first example, it's okay if you're like, because you've never seen this before. You'll see in a couple, it's the same steps every time. Step number 1, solve it like before. Step number 2, put them on a number line. Step number 3, pick some values, test true or false, state the true intervals. X squared minus 7x plus 12 less than equal to 0. Step number 1, solve it like there's an equal sign. I'm going to factor because I like factoring the best. That's what I heard. Would you like to confirm or change? And then when we solve x equals, and x equals. Okay, so step 1 is just like unit 3, nothing tricky there. Step 2 is the number line. Again, if you would rather for the number line put all the little ticks and write 0, 1, 2, 3 all the way up and negative 1, do that. I just get lazy. I just put my 2 values. And just make sure you're doing them from smallest to largest. So what's going to come first, 4 or 3? And then okay, I'm going to do one of these things where I tell you something, but then next year it's going to turn out to be false. Okay, for this year, did you see how the intervals flip-flopped? We started with a true, which was the first interval. The second interval was false, which made the third interval true. They will always flip-flop till next year. If the first one is true, the second will be, and the third will be. If the first is false, the second will be, and the last one will be. So use that to your advantage. What I do is just find the one that's going to have 0. Which interval is 0 going to be in, the first, the second, or the third? 0 is going to be over here. So I only ever test 0 because if you know one of the intervals, you can get the rest of them. Again, that won't be true next year, especially if you take calculus, but for this year, that will always be true. Because we're going to get into quartics, which then this will all fall apart. But because we're only dealing with quadratics, it's going to be true. So I find 0, and then I just go to the question. I just don't look at anything with an x, because I know they're going to be 0. And so I say to myself, 12 less than or equal to 0, true or false. Then I don't even really test the other ones. What do you know about the middle interval? And then what do you know about the last interval? Got my little short trick there? Step 3 is just picking the interval, and then, sorry, step 4 and writing the answer. We always want the true interval. How do I say those numbers between 3 and 4? So that's not to the left and to the right now, it's between. How do I say between 3 and 4? 3 less than x less than 4. Always that less than means between. And the last part of that step, I just check the question. If it has an or equal to, final answer, 3 is less than equal to x is less than equal to 4. Again, you don't really need to know, but graphically what's going on here is we have an upward parabola between 3 and 4. It's crossing at 3 and 4. I should put it over here. And because this is less than, we want the ones that are below. That's what the number line is doing for us. It's getting all those points that are below.
So if it's between, it'll always be
Less than, always. How's the second one compared to the first? Getting easier? Especially that I showed you the shortcut there. What do you mean by opposite? Always. Okay. Until next year when that's a big fat lie. Okay. Grabbing my red pen. Do you remember when we did the discriminant? The b squared minus 4ac. And we talked about the number of roots. And we talked about if it's positive, then there are 2 roots. And if it's 0, there are 1 root. If it's negative, 0 roots. And then we did those applications, solve for k if there are 1 root or if there is 2 roots. And there was a trick I told you about inequalities and something with dividing or multiplying by a negative. It was a rule from grade 9. Anyone remember that? Is anytime you divide or multiply by a negative, you have to flip the inequality. Let's just write that down in case that's important. Anytime you multiply or divide by a negative, anytime you multiply or divide by a negative, you must flip the inequality sign. Anytime you multiply or divide by a negative, you must flip the inequality sign. Again, that was a whole class in grade 9 it took to teach you that. Okay, so you've seen 2 examples already. I think it's time to stop and have a quiz. What do you think? I'm actually just trying to scare her out of her hiccups. Let's see if that worked.
It actually hurt. These hiccups are painful.
Very good. I was just trying to scare her out of her hiccups. So, I want to factor because it's the easiest method. The problem is I don't want this negative here if I'm going to pick factoring. How do I make the x squared positive? Divide everything by, divide by what now? A what now? What's going to happen when I divide by this negative? If you forgot that, the rule that you have to flip, what's going to happen is you're going to pick the wrong intervals at the end. Okay, so we have to make sure we're dealing now with this less than interval because we divided by -1 to factor. I heard like a really quiet -5 and -1. Confirm. I'm totally not stopping if it's wrong. Might want to really, really confirm it. Okay, so x equals? And x equals? What is going to happen when you're in exam panic is you are going to stop there and you're going to think you're done the question. Because that's what we did in Unit 3, and we're so used to stopping when we get the answers. Why is that not the last step? because it's an inequality, not just an equation. So this now becomes number line, intervals, testing, true, false, blah, 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 blah. Blah, blah. That's an actual official step. I want to jot that down. Which number am I going to put first, 5 or 1? Why? Because it's the smaller of the two. Which interval is going to have 0, the first or the second or the third? Now you just need to make sure you're coming back to our less than step, not the original, because this is what we factored from. So we go 0 squared, don't care. Negative 6 times 0, don't care. 5 less than or equal to 0. If the first one is false, what does the second one have to be? If you don't believe me, you can pick a number between 1 and 5 and you can test it. It will come out to be true. What's the last interval if the first one's false and the second one is true? If you don't believe me, you can pick any number greater than 5, put it in, test it, it's going to come out to be false. Which interval do we pick? Always? Yes, it doesn't make sense to pick the false intervals because they're false. They're not true. How do I name or how do I say in math this middle interval? But I think you meant 5. Why did I put the or equal to's there? Because they're in the question. I think her hiccups went away. I think the quiz might have scared them. When I was your age, I used to scare my mom's hiccups by telling her I was pregnant. Worked every single time.
Wait,
Worked every single time. Doesn't work so much now, but. Questions? It made the hiccups go away. Are you starting to see the similarities between the questions? Exact same stuff every single time.
Just to make sure, so the
Yep.
0 we put for like the very first one, you plug that into the original formula?
Well, not the original.
The
Yeah, yeah. And so we had 5 less than equal to 0. False. Do you want to try number 5? I heard kind of a yes/no there. I was thinking individual, but. Okay, how about you guys say the step and I'll write it down. So you're kind of doing it together, but. Someone's got to say it.
plus x minus 3 greater than 0.
Now, if you think you're going to go back to the original, like cross it out. Like, I'm not kidding. If you think you're going to go back to that top step when we're testing, like just get rid of it. Pretend it's not there. Then your brain's not going to go to it. How many ways are solo quadratic? There are 4. What method would you like to pick? We can do a fun complete the square. It'd be some nice fractions. Be awesome. Be nice. If we didn't have fractions, we couldn't share stuff.
I have a, actually, I do have a question. So for the last 2 questions, whenever you get to this step, you always put equals 0, but this time you put
Oh,
does it matter?
no.
Okay.
That's just me being sloppy. Doesn't matter. So not doing it for you. But I will write down whatever you want me to.
Negative 3 and 4? Wait, just kidding. I have to do the thing first.
Kind of feel like you're waiting for the factoring fairy to come down and wave her magic wand. And
3, take away 3x plus 4. X plus 4x.
I'm just writing down, then you guys can debate or discuss. Or Because we taught you this in grade 9, and we taught it in grade 10. I taught it again in grade 11. Guess what's going to happen in grade 12? Oh, it's coming back. How about we start with the product and the sum?
Product of 12, sum of 1.
Where did the negative 12 come?
Negative 3 times 4.
This is just not good. The sum is 1. Okay. 4 and negative 3.
Yes.
Didn't we have that? Oh, yeah.
Oh, yeah. Okay. Right, factor it out.
I feel like that shouldn't have been that difficult.
Yeah, I know. Just like, why is it so hard?
Yeah, so we're factoring out 4x. Bracket x plus 1. Plus 1, yeah.
I wasn't trying to get you, but I'm happy.
I keep breaking this.
Oh, okay, I remember this now.
4x minus 3. That was a weak episode. Very, very weak
Yeah, why was that so?
Jesus.
I'll chalk it up to Thursday. I don't know.
Well, x equals negative 1 and x equals positive 3 over 4.
Oh my God, there's a fraction. I don't know how to put that on a number line.
0.7.
Because clearly fractions don't go on number lines.
Why was that so hard? That's so good. In the middle.
Figure out if it's true or false. It's gonna be false. What's the equation? 0. Negative 3 is greater than 0 and is false. So it's like true on each other side. We're really not saying any words that I don't know you.
Listening to you guys, it's kind of fun.
Because we're a big joke.
You guys tell me.
I only know this is in between. Yes, he is right.
The non-in-between will always be less than the first one, greater than the second one, always. Because it's to the left and then to the right.
Wait, if it's not in between the first and
Always less than, always greater than.
then?
You can cross off example 6 because we don't do